All right, we've got another composition here. This one's a little more complicated in that I'm dealing with a rational expression. So, I'm going to be looking for Q of P of X. Now remember, the best first step I suggest students take is to go ahead and to rewrite that as a function within function. So this would become Q of P of X. So that, again, guides me as to what my plan is. Now when I look at Q, I have two variables. The X appears twice, which means that the P function, x squared minus 1, is going to appear twice in the result. So this composite is going to become, I take my Q, I'm going to replace each X with what P is. So I'm going to end up with x squared minus 1 over x squared minus 1 minus 1. So I've plugged in P of X for Q. Plugged it in, now I simplify, which gives me x squared minus 1 over x squared minus 1 minus another 1 is now minus 2. And that would be my resulting composite. Now when I talk about domain, I ask myself, for what values does this not work? In a rational expression, you can have a 0 in the numerator, but you're not allowed a 0 in the denominator. So I want to see, well, where is x squared going to equal, x squared minus 2, going to equal 0? Well, that's going to happen when x is equal to the square root of 2. So my domain for this is going to be the set of numbers of x such that x does not equal the square root of 2. All other values are going to work, so I say it's all the x's except x is equaling the square root of 2.